Welcome to our last lectures on the DC microgrid and control. Today we shall summarize our course content and its advantage and what are the challenges available, so that research scholars or the practitioner technician practitioner engineers like you people can address those channels. So, this is we shall discuss about the general summary of the DC microgrid. So, we have, please refer to our introductory classes. We have discussed why microgrids, what is microgrid and all those, and after finishing these courses we were aware of those entities, and that is what we can say that DC microgrid, why it is important is that is an electrical system that can efficiently distribute, consume and potentially create and store DC electricity to power a variety of the electrical devices in and around the building when connected with the utility grid or in an islanding mode. This is the one of the entity, and with the penetration of the solar and the storage device being battery. So, we have it is better to have a direct DC to DC conversion instead of have multiple point conversion of AC to DC or DC to AC. The microgrid differ from the electrical grid by providing a close proximity to the generator and the power use, resulting in efficiency increases and transmission loss reduction. Please go back to the old battle of Nikola Tesla and one of the main advantage of the Nikola Tesla with the AC, that you can step up the voltage and thus conduction losses will come down, and generally load centers and the generator units are being divided by the space. But since this space is no longer existing, and thus you have a potential to reintroduce the DC, and they can be connected or disconnected from the grid to enable it to operate in both grid connected or the islanding mode. Thus you may have a distributed generations, most of the cases with these microgrids, in small electric power system independent of traditional utility grid. It may be a solar, or you may have a biomass which is located on the user side of the user side to meet the end user's demand. Different DG sources such as solar PV, wind, fuel cells and so on are utilized in the microgrid application. So, you can harvest power. So, the consumers can also be the earner of the power. With a small size and high flexibility, we have seen different kind of architecture of that DC microgrid or the microgrid in our initial lectures. Our distributed energy system can satisfy the load demand and also solve the difficulty of long distance transmission losses. So, you do not have any D&D losses, because transmission losses will be 0 because you are very close proximity to your load and source. Another main aspect was in distribution system was, since the consumer is an entity and the supplier is another entity, they are in a mode of conflict most of the cases. The condition of the theft and all those issues are there. And two, you may, as since you are making the consumer also the stakeholder to this microgrid, due to this involvement and participation, those activity has been drastically reduced. A microgrid controlled distributed generation and the storage elements and the load coordinates themselves with the control system to form a single controllable power source and is directly arranged to the end users. So, this is something we have to understand. This whole itself is an entity. Microgrid is controllable entity for the grid and from the user side, and it can meet the unique demand. So, you may have a particular functions at the particular microgrid. So, it can fetch little bit more power from other microgrid, and it can share and reduce the feeder losses and ensure the local voltage stability. So, you may have a peer to peer networks and all those entities we have discussed, and that by that applying we can ensure the local voltage stability. And this energy storage element and DGs, that is distributed generations, are combined to address the problem of significant fluctuations of the DG outputs. So, that is something we require to keep in mind. Moreover, DG can be connected to the grid through the power electronics to regulate the PQ control, that is active reactive control. Once you are injecting or taking power from the grid, we have to maintain the grid code and the voltage output or the DGs for the improving the grid reliability. Sometimes we may feed the reactive power if required to grid stabilization and all those issues. A microgrid should operate at standalone in region where utility supply is not available, or you have a blackout for some days, in grid connected mode within a large utility distribution network. So, this is also possible. So, its flexibility is more. Microgrids need to be designed properly to take care of their dynamic impacts on the main grids, such that overall stability and reliability of the whole system is significantly improves. So, that is the whole idea of the microgrid. So, it need to be designed properly to take care of their dynamics impacts, that is the load change or adding up a plug and play kind of devices or main grids, such that the overall stability and the reliability of the whole system is significantly improved. Microgrids are, we have already discussed those, again we are just recapitulating: DC microgrid, AC microgrid and AC-DC hybrid microgrid based on their voltage and the current types. And our discussions was from the microgrid, we gradually talk about more about the DC microgrid. Please understand, to understand this, first we require to understand the microgrid. So, for this reason in first few lectures you will find we had discussing all these three type of microgrids, because DC microgrid sometime is existing as a hybrid microgrid. And so, while you are studying a DC microgrid, we require to understand its interaction with the other microgrid present to the system. In DC microgrid, this DGs, distributed generation and EC, and this energy storage and the DC loads are connected to a DC bus via the converter, and this DC bus is connected to the AC load via an inverter to supply this DC and the AC load respectively. So, we may have a conversion, and that is useful also, because once you are converting AC to DC, thereafter AC, then you are throwing garbage to your AC system. So, once you are converting only DC to AC, that entity is missing. In AC microgrid, the distribution network is connected to the AC circuits by means of the circuit breaker and the AC bus control the microgrid operation system through the circuit breaker at the point of common coupling. So, this is quite easy to connect. So, you have a circuit breakers and the isolators, that is a way generally how the substation power comes to you. But in case of the DC, we require a active rectifier. The 3-phase AC bus is commonly employed as a point of the common coupling. Please understand that if the load is more than 3 kilowatt, generally we require to go for the 6 phase 3 phase. So, AC/DC hybrid microgrid is a microgrid consisting of the AC bus and a DC bus. In islanding microgrid, all the generation unit are connected to common ground or common grid via converter, and there is no inertia of the rotating masses to affect the frequency. This is one of the very big disadvantage. So, since you do not have any rotating entity and since you have only the switching devices, so inertia of the system is much less than the conventional your synchronous generator. So, inertia will come down. For this reason it requires a very fast action of the controller. Controller has to act quite fast compared to your SCADA and conventional grid. In such cases, the frequency is created by the power electronics devices. Students are requested to see that white papers of the any solar company, for example, there is a German company like SMA, white papers of SMA with their off-grid solution. So, they have that particular entity is called Sunny Boy, and it forms the grid and all other inverter follows it. In such cases, the frequency is created by the power electronics devices, so that at least one unit creates the frequency reference for the other generator to synchronize it. Please mind it, while in case of your in case of the normal synchronization, your biggest generator generally sets the frequency, but here it is not the so. You can make any solar unit, any unit can be a your setting up the frequency. We have discussed these entities in detail in our previous lectures. Generally energy resource like the entities which has a maximum power handling capability generally made to control the frequency, like battery and solar may be at the point it is controlling. Synchronization with the utility grid voltage is an important matter for the variety of the grid connected power electronics converter in distributed power generation system. So, we have to require to see that what is the point of entry, so that we can give the redundancy. If the particular converter is non-functional, you can manage to send power through the grid or you can take out power to the grid. So, this kind of architecture we have already discussed, and this is one of the important criteria while the power converter control and the operations of the microgrids. So, power flow is controlled by adjusting the voltage phases and the magnitude between the inverter and the network to control the current flow. The electronically coupled DES units utilize power electronics converter to match their characteristics. This unit involves distributed generator units based on the variable speed wind turbines and their REs, micro turbines, internal combustion engines, sometime it may be there, or the generator along with the distributed storage may be the batteries and the plug-in electric vehicle, all comes into the pictures of this microgrid as an entity. So, the control scheme of DES within the microgrids are designed on the basis of the required functions and the possible operating conditions. The power electronic P reference also contains the monitoring and the control functionality to ensure that the distributed generator unit, that is DES system, can operate as required. So, it may require to PQ control, it may require the droop control for the DC microgrid, it may require the VYF control. So, all those entity can be factored into this distributed generation by the power electronics interface. Monitoring functions is typically include a real time real power and the reactive power and the voltage monitoring at the point of this D connections with the utility with the PCC. So, that is the requirement. So, you require to have real power, reactive power and the voltage monitoring, generally that is the entry point of the grid to the microgrid. So, microgrid can work either in grid connected or islanding mode to obtain uninterruptible power supply for the loads. ESS play an vital role in microgrid in order to maintain the stability and the robustness as well as to improve the power quality of the microgrids. In DC microgrid, power converter used to interface source and the loads and also the interface to the microgrids. The DC microgrid decouples the frequency, voltage and the phase of the various AC generations and consumption element in the microgrid by use of the suitable power electronics converter. So, this is the part of the DC microgrids application in the power electronics. So, understanding the dynamics of the microgrid, that is one of the important entity that we require to consider. Understanding the dynamics and the using appropriate modeling of the microgrids are significant issues for the microgrid control, synthesis and the stability analysis. Dynamic analysis is required to ensure that the microgrid operates in a stable manner with control voltage and the frequency fluctuations for interaction with the AC/DC microgrid or hybrid microgrid. Particularly transitions from grid connected to the islanding operations may pose several challenges. That is something we require to address also. Depending on the configurations type and the components, the microgrid dynamics may change, and for the different application and the different modeling method may be required. We have seen that we have applied different control strategies, different modeling strategies to better understand of the dynamic characteristics of the microgrid. The increasing penetrations of small size renewable energy sources into existing microgrid has created a new sort of challenges in the power electronics engineers. That is something we require to address it being a future researcher. One of the most significant challenge is that the most of these renewable energy sources generate either DC output or variable frequency or else the variable voltage AC output. That is something that we require to address it. Presence of the source, because solar based on the irradiation will change. If you have a CPLD, current value will change if you change the voltage. So, ultimately there are a lot of hodgepodge into the system, and we require to address this challenge. Presence of these sources creates a new challenges to maintain the stability of the existing grid, because you know that in case of the synchronous generator, it will inject the power to the grid at a constant voltage, but it is unlikely in case of the microgrid. So, solar will give you the voltage depending on its irradiation. Therefore, a suitable architecture is required so that to manage the power flow within the different micro sources within the microgrid. Now, microgrid integration, that is also one of the important characteristics. To coordination of the resource of the load can be based on either centralization or the decentralization approach. This has been discussed. Among the various sharing strategies, Our droop method is one of the algorithm, and that is commonly applied for the decentralized strategies, and we prefer also the decentralized strategy to reduce the loading of the centralized system. There is also an option to include the bidirectional DC to DC converter for the AC grid interconnections, so that power can flow from grid side to the microgrid and vice versa. And thereafter, since the generation peak of this renewable energies and the demand peak because of the behavioral pattern of the human being are not same, and for this reason we require power storage, and storage is required to smooth the power output from the renewable energy sources, and you can make a zero peak billing like that. The utility grid connections and the billing distributions bus connections are made by static state or the hybrid switches. The microgrid should be able to optimize the power flow on the bus to obtain a minimized daily cost for the end users. That is something we want to ensure. The microgrid control includes voltage and the frequency regulations, real and the reactive power control, load forecasting. So, that is something from the pattern of the history you forecast it, scheduling, because you want to change that particular pattern of the behavior gradually with the consumers, so that you can try to match these peaks of this input peak of the generation peaks and the load peak close to each other, so that size of this storage element reduces, and the microgrid monitoring and the protection. Protection is very important issue, especially in the DC microgrid, because it does not have a normal 0 as explained in case of the AC system. And generally we have discussed in detail all these three control, that is the integration. Depending on the distributed generator and the operating conditions, there are three main types of the control. One is active reactive power control, voltage frequency control and the droop control. PQ control is based on the grid voltage oriented PQ decoupled control strategy, in which the outer loop adopts the power control and the inner loop adopts the current control. So, that is the something we require to follow. We have discussed in detail in our lectures, please refer to those lectures. And thereafter, the main objective of the V by F control is to maintain the system, because if you control the system frequency V by F control, if you do it, then flux become constant. So, the AC system which can have in case of the AC microgrid can runs very well. So, of course, it is for the AC microgrid or the hybrid microgrid, not for the DC microgrid, but you may have such that one microgrid is running close to you is a V by F control, and another you want to integrate it to the DC microgrid. So, then you may go for the PQ control and we require to switch over. As the microgrid is designed to be an autonomous system, the operations is supported by the power in the energy management system, and some smart features are expected to present. What happen if you do the V by F control? Then what will happen if you just reduce, since assume that your power is low, and thus you have made V by F control. So, what will happen? Your torque will remain constant, but speed will come down maybe little bit, and thus you may your fan may run 5% less speed, but you do not even not feel that it is running at a 5% less speed. So, this is the beauty of the V by F control. Whole idea of the microgrid is to give proper energy management with least discomfort to the consumers. So, through the proper settings of the droop efficiencies, the net power change can be shared among the different DGs in order to achieve the dynamic power balance and maintain the voltage and frequency within the acceptable range of the unwinding mode. And another, we have discussed the topologies of the microgrid, we just recapitulating it again here. These are unipolar and the bipolar microgrid. Nowadays, we have seen that bipolar microgrid gives you more redundancy. So, nowadays this RES, such as energy resources such as PV panel and the energy storage element are increasingly getting integrated in the distributed power systems, and thus you may have a unipolar topology, you supply plus and ground or 0, and you supply plus minus and ground, and thus you have a redundancy. If one line goes off, you can still keep on supply on the other line. However, capacity of any distributed energy system is very variable and uncertain due to the dependency on the weather condition, is extremely variable and is uncertain due to the weather condition. So, now what you have, based on that we have to ensure the redundancy, we have a different kind of configuration. These are the radial configurations, ring configuration, interconnected configuration. We have seen in detail all those configurations, and we have to choose accordingly. If you wish to give a more redundancy, we will choose maybe the ring or loop configuration. Thereafter, we may go for the interconnected configuration to give proper adjustment of your redundancies. Now, stability, this is the thing we are discussing for past few lectures. Stability of the microgrid is a very big challenge because of the nonlinear issues, and you have a CPLDs, you have a penetration of the CPLD. You want that the system to be a plug and play type. You say you wish to switch on a fan, you do not bother to put a switch. But in case of the microgrid, small load change can be designed and properly taken care of by your small signal analysis of the control system. But if there is a huge load change, so then generally it cannot be taken care of by the small signal analysis. So, thus what happened, the stability aspect of the microgrid refers to the ability to maintain the power supply and the load without unwanted dynamics such as voltage and the power flow oscillations. And thus what happened, microgrid has to operate in a disconnected and islanding mode, and generally we see that which mode is preferable, and each operation mode have a different characteristics, different stability analysis. Now, for this is what I was discussing. We have a large signals as well as small signals. Large signal stability refers to the stability of the system or to withstand a large variation of the perturbations, and for this reason we find that nonlinear control, feedback linearizations or the sliding mode control are better, and in case of the small signal analysis we can apply to our normal control system. Now, microgrid and the control power management, that is also an issue. We have to have an integrated system, proper power management record to be placed, and we may have a different kind of approach. Another one approach is a centralized approach. The centralized approach takes all the information from all the energy resource and the DGs, and then it gives the instruction. Otherwise, you may have a decentralized approach, decision taken in a distribution fashions once DGs and ECs are controllable to the local load. So, generally for this redundancy and all, we prefer the decentralized method. And apart from that, so this is that when the renewable energy resources such as PV, wind are interconnected, the power fluctuation of these distributed energy sources can be compensated by integrating the storage element. So, sometimes you have a grid firm commitment, so you can ensure that this commitment by the storage element. The local controller have been employed in order to perform the independent and the simultaneous control, and they generated the active and reactive power, and some new control capabilities has been developed in order to create a new possibility to manage the control and the power system in presence of the renewable energy system. So, there is also some challenges for this proper control and the power management in case of the DC microgrid. So, thank you for your attention. We thus conclude our course on DC microgrid, and these are all the entities, that is broadly which we were covered in our last classes. These are the potential research topic for all the researcher, that is the microgrid and the power management. Thereafter, we have talked about the stability of the microgrid. Also, student from this power system background generally prefers to work or will work in the power management, and definitely control and stability aspect should be taken care of by the power system people and optimizations people. Thereafter, we have a topological aspect of the microgrid that can be well addressed from the students or the researcher or the practicing engineer from the power electronics background, and there the integration also comes under power electronics some extent. And thereafter, we have a dynamics of the microgrids, then again it is a control entity. Thus, and again we have, I am silent because I am from the electrical background. So, there is a huge challenge also to incorporate communications, especially in the centralized control scheme. So, thus DC microgrid is a multidisciplinary subject. It takes the input from power electronics, it takes the input from the control, it takes the input from this power systems as well as the communications and instrumentations. It rather takes input from all the entities and thus come out as a concept. Thank you for your attention. So, you have studied a power system instrumentation. Now, we should have a microgrid system instrumentations as a new course. So, application, we have seen the power electronics application in the large distribution system like fax. Now, we have a microgrid applications, and we may also have a load flow studies for the microgrid and harmonic studies. So, all those what we have seen in a large scale, it has been boiled down to the single point, the DC microgrid, and it has a huge potential and advantage, considering that we are going for the more renewable. We are talking about now zero peak building, we are talking about the zero emission building, where all those entities has a huge potential. Thank you so much for your attention. We shall looking forward, hope that this course will be beneficial for your future learning or as a research practitioner or the research scholars in the field of the microgrid. Thank you so much indeed.